Well, I'm going to wait a couple of minutes to see if I get anybody connecting. Other than that, I'm just going to make a video demonstrating stuff. I'll wait 2 minutes for this. Aha. Good. Hello, Mike. I'm going to wait another couple minutes before I start the demonstrations here. See if there's anything interesting in the news. Oh, it looks like for the last couple of days it has been failing to save my news links. I seem to have lost all my cookies a few days ago, and that's probably why. So all I got is my older news links here, such as Life. You go here where they are. This one might be interesting, and that's probably, yeah, these ones are pretty interesting. So if anybody, in case anybody doesn't know, VPNs don't work very well. Most of the time they leak information. And this guy found 10 out of the 14 ones that work as browser extensions, 10 out of the 17 ones leak DNS, because when you load a page like this, Chrome finds the links and starts looking them up right away before you click on them, and the browser extension failed to pick that up and anonymize that. So that's a thing that I think a lot of us knew about, but it's a thing to be aware of if you aren't, that VPNs are not likely to really protect your privacy as well as you would like, unless they're properly configured. Soon, I think, we will switch to DNS over HTTPS. At least that's what I like. I'm not seeing a whole lot of rapid movement towards it, but I know Cloudflare now supports it on 1.1.1.1, and it would be a very good thing. This is very interesting. A couple days ago, the WhatsApp founder quit WhatsApp, which merged with Facebook, and now the dirt is coming out that this is exactly what you would have guessed. WhatsApp was a privacy company, and they were very much opposed to targeted ads. And when Facebook bought them, they removed the privacy so they could collect the data from WhatsApp and target ads and sell it to people. And they pushed this more and more until they wanted to lower the encryption in WhatsApp so they could more efficiently use it to target ads. And that's when he jumped ship. So it's they've actually, the other co-founder, Brian Acton, actually joined the Delete Facebook movement and actually put his money on another competing product, Signal, I think. So in case anybody imagined that Facebook had changed their practices and were not going to be invading your privacy, that is certainly not true. I don't know how they could anyway. All right. So have you got any questions, Mike? Put them up in the chat if you do at any point. Otherwise, I'm just going to proceed with what I had ready here, and I'll make a video, and some people may want to watch it later. And the thing I want to do is more of these Nebula exploit exercises. I found this recommended on that pen tester lab thing, and I've been going through them, and I moved forward to Protostar, which looks even more closely aligned to my classes. But I found 3 more levels of Nebula that were pretty fun here, and I figured I'd demonstrate them today. 13, 14, and 16 are ones I like. There are write-ups of these online in blogs, which is very helpful, because this one here baffled me in that I could not even understand what I was supposed to be getting. And so I wrote alternative instructions. But let me bring up their instructions. Their instructions are here. This is at exploit-exercises.com/nebula. And here's their description. There is a security check that prevents the program from continuing execution if you don't match a specific user ID. And so here is the source code in level in C. So after loading some variables, it defines this global fixed constant called fake UID of 1000. And then it starts and it checks to see if the user ID that launched the program is equal to fake ID. And if it is not, it fails and kicks you out. then they've snipped some code here and hidden it from you, and then it prints out a token. And I was on the wrong track immediately. I thought that somehow, because I see 256 up here for a token and down here you print it, I thought maybe there's a buffer overflow for the token, but I couldn't find any way to get down to this code. So then I thought, because I saw this unusual char star star NP up here, that it was using environment variables, and that somehow there was a way to use an environment variable to change the value of this constant. So I spent a while researching that. Hey there, good. And so I'm doing exploit exercises, okay. Level 13. So this is one. I've got 3 of them I can demonstrate, and then I'm happy to answer any questions. So this one here is a C program, and it reads the user ID with getUID, and if it's not equal to 1,000, it stops immediately. And so the account you're told to log in with is account 1014 or so it doesn't work. So that's the problem. And what I did not understand from their instructions is this token here is the password you need. And your goal is to just get past this to get down there to execute that token. And all right. And if you disassemble main, this is where you want to, right. So, and here's the trick is very simple. As frequently, I got off in this complicated thing with environment variables, but the point is, you need to get to this part of the code, but you do not need to run it as root. It doesn't read this from a file. And the clue for that is, if you connect, let me get I'm running the virtual machine here, Nebula, and so it's 172.16.1.130. So it's level 13 at 172.16.1.130. Whoops, that's wrong, 130. Okay, and level 13. So once you're in, the way these Nebula things work is you end up in a home level 13, but all the flags are in home flag 13. And most of them are SUID files. And so is this one. So it's going to run as flag 13 with those privileges once I'm inside. But the point is, it doesn't really need those privileges to do the job. It would be sufficient to run it with low privileges if I could get past the test. So what you do is just modify the code. Now, if you were to make a copy of the code and edit it and save it, you would lose this S in the permissions here because you don't have the authorization to make an SUID file that runs as flag 13. So what you do is run it in the debugger and just modify it there. So I run flag 13 here, and now I can disassemble main and see what it does. And as usual, you just look for the names of the functions. So here's the getUID. Then it compares it to 3E8. And this is what, it took me a long time to get here, but this is why my whole idea of changing environment variables was completely off crack, because this is just a hard-coded static constant of 1,000. So there's no way I can change that. So what I need to do is just modify this code or modify the registers at this point. So here it's going to compare this to EAX, and this call loads the EAX from the user. So it'd be simple enough to just stop at this point. I'm going to break at main plus 48. Okay, and then just run. I get to the break point, and now I am at 4F4, which is this. I'm now about to compare 3E8 to EAX. So if I info registers, I can see my EAX contains 1014, so I can just set EAX equal to 1,000. And now if I do info registers, now it's 1,000. Now I just continue, and I get the flag. So it is very easy, and that is the password that will let you log in with the other account. And I'll just finish the whole thing, because the difficult thing about these exploit exercises is that the goal isn't very obvious, and sometimes the instructions aren't very obvious. So once I have that, I can quit the debugger, and now I can do a switch user to flag 13. And now I need that password, which I paste in. And now you're supposed to run get flag. And this will always give you this message. You have successfully executed get flag on a target account. Apparently this was once a real CTF with real flags. This is what you're supposed to do. Run get flag and get that message. That proves you're in. If you don't have the right privileges, the get flag will print this and that doesn't count. So that constitutes success in this one. And it's sort of useful to see how to use GDB to modify things. All I had to use was set to change a register here. I could also have modified the code to jump over that test, or there's a lot of ways to do it. So that's the first one, level 13. Now level 14 was even easier. Let me show you that one. This one here, I again tried some complicated things and then I realized there is a very simple way to get there. So if I SSH in to level 14 with the password level 14 and then go to flag 14 and see what I've got. I see I have a flag and a token. And if I cat the token, this is some kind of scrambled junk in this file name token. So now that I've got some orientation, let's look at the instructions, which are here, level 14. Okay, the program resides here. It encrypts input and writes it to standard output. An encrypted token file is there. Decrypt it. That's all you get. Now, I took the code and put it in Hopper and made pseudo C code and started reading it to try to figure out how it decrypted things. And then I decided rather than bother all that, let's just play with it a little bit. So if I run flag, and it turns out to be so easy to black box that there's no reason to look at the code. So if you run flag 14, it tells you its only option is E to encrypt input. So I use E, and then I give it a value of A, and I get an A. Okay, and the first time I ran a few lines, if I do A and then do A again, I keep getting different answers for A. So that's the carriage return is not terminating input. It's just printing output and continuing. So I'm going to restart it every time to get a fresh start. The first thing is to notice there's nothing random. Well, okay, if I run this, if I encrypt A, I get that. If I stop it and run it again and encrypt A, I get A. So if I run it again and I put in AAA, I get ABC. And this was my first clue that I'm dealing with a very simple cipher here. So I just tried a lot of A's. And you get just alphabetic going up. So it is actually immediately obvious what you've got here. This is just a Caesar cipher where you increment the first letter by 0, the next letter by 1, next letter by 2, next letter by 3. So it's a little more complicated than a standard Caesar cipher, but not much more complicated. And to see if, I worried about how it might not wrap around at 256, but maybe 127 or maybe just the alphabet. So I tried a lot of A's to see what would happen. And it wraps around. It looks to me like it goes through the whole ASCII, and then it does all the non-printable characters, and then again. So I think it just wraps around by 256. So that is so easy. I can just trivially fix that in Python. So I wrote a little Python script that will do it. And here it is. So if I can put it inside this thing if I want to, but I have to rework in the temp folder. So let's make it temp level 14.py and put it here. So this will read token into a variable called ciphertext and then print it and then shift it back. So I'm going to just stop it here for now. Talk about it in a few stages. Okay, so now if I do Python temp level. Okay, so remember the ciphertext was here. I forget what it was called, token. Okay, so it looks like I've successfully read this in. I read in this junk, including the non-printable characters, and printed it out. So now my Python code does, let me get rid of the colors and make this as big as I can. Okay, so all I do is I set a variable called clear. I've gotten very used to doing this for decrypting in Python. I set a variable called clear, which is going to accumulate the answer, and the shift starts at 0 so this will take each letter in ciphertext one letter at a time, takes the numerical value of it in ASCII, subtract the shift, wrap it around 256, and then add that character back to clear so it will gradually build the clear. And that's all I need. So if I run that, that gives me, again, the token, which is the password to log into the other account. So that's pretty good now that I understand how these things work. All right. And there's one more of these I wanted to show you, which is level 16. And this one was pretty cute. So let's go to the instructions. Okay, this is a Perl script, and it is listening on port 1616. And it took me a little while to figure out it's not index.pl, it's index.cgi. So you can actually see this in the browser. If you go to the address of your Nebula machine, which in my case is 172.16.1.130, you get various error messages when you get it wrong. But when you go to port 1616 and then you go to index.cgi, then you see the page they intended you to see, which is your login failed, would you like a cookie? And of course, I didn't see anything in the code that had to do with a cookie, and I checked and there is no cookie. This is just a blind alley, but your login failed. And if you go back here and look at the code, this is Perl. It's going to read parameters in from the input. The parameters are going to be username and password. And then it's going to convert to uppercase, strip everything after a space, and then try to use egrep to find a line in the userdb.txt that starts with the username and then find the password after a colon. But the reason why this is not going to work is because there is nothing in that database. Let's connect in as level 16. And then go to where the flag is. And you'll see there is a file called userdb.txt, but it's size 0. So there is nothing in there. So there are no valid usernames and passwords. So once again, I spent quite a while going down a blind alley. I noticed this trick at the end of this, 2 greater than &1. This is going to take the standard output and the standard error and put them both in the standard output. So I thought the trick was to somehow create an error in this command that would put out an error message, which would then be possibly interpreted as a username and a password. So I could trick it into creating an error message that would make a password I could predict. But I was unable to find any way to make this command put out anything at all, so it never enters this for loop. This for loop looks for lines in the output from that command, and I can never get any output. So that led nowhere, and I went to somebody's blog that solved it, and he pointed out the other thing I wondered about, there's a command injection vulnerability here. You're doing a grep command in the command line with username that came from the user, and I tried to exploit this because the way I'm used to doing things from SQL injection, where I put in the missing quote, and then somehow fix the syntax of this line, and then put more commands there. But there's an easier way. I found 2 separate ways to do this, which taught me more about command injection than I'd known before. So here's the simplest one, is to just put in a single quote and then put in a command in backticks. And the reason why this took me longer than it should have is that you can't see the output of the commands, which is something I'm getting used to from the other CTF type things we'll be doing. So notice up here, it's username and password. So the way you feed those in is you put them right here in the parameter, username equals foo and password equals bar. Okay, now the login failed, but this is how you put in username and password. Now, I thought my injection was not working when I tried stuff like this and then like date, semicolon, and say pound. Now, what that should do is it ought to end the quote. Then I guess I could have a semicolon to end that one. Then I do actually the date command. Then the rest of it's a comment. So I run that, and I get the same response. And this is what I'm learning. Of course, I get the same response because these command line commands don't feed output that comes back to me through the HTML. They're working, and the way to find out they're working is it works if you put backticks in here. And the reason you can tell it works, you can't tell that the data is working. So what you do is you put in something that will waste some time to see if it's working, like ping -C10 127.001. That will take 10 seconds. And let me see, I probably got the syntax a little wrong. Oh, I made my own version of it to run with that in there. And I didn't bother with the quotes. So let me just see if it works without the quotes or the semicolon. There, if that's just my username. Let's see what that does. Nope, still didn't take any more time. Anyway, I made my own version of it. This is another way to go, by the way, which I should mention in case you have, since this is Perl, I just put the Perl on my own server and ran it directly. And then I could add more comments and I could remove these things and mess around with it. And by the way, this is probably why things are failing. It's turning my ping to uppercase, so it's no longer recognized as a command. So there are various solutions to that. And the simplest solution was this, which is a cute trick I had to learn from somebody's blog. I didn't know this. So suppose I make a script. I'm going to go nano/temp. It might still be there from before. Yeah, I made a script called win, which will open up a shell and get the flag. And I'll put the output of the flag in a temp file where I can find it. So I'm going to make this win16b, a file that doesn't already exist. So if I succeed, that will go in there. Now, if I just run that, /win, and then I look in there, /temp, I already forgot what it was. Let's look at cat /temp/win. It was that, temp win16b. If I look and see what the output was, this is failure. On a non-flag account, that doesn't count. So I'm going to remove that file. Okay, now here's another cute trick that I learned from a blog. Remember, I only have uppercase characters, so I can't do cat, I can't do ping, I can't do who am I. But you can do this, which is news to me. You can do a star in the path, and then have a file name with a capital name. And this will try various directories, including the temp directory. So it will, in fact, find it and run it. And now if you look at the output, it ran. I haven't won yet because I just ran the file, but I have figured out how to execute a command with just uppercase characters. And now that I've done that, let me remove the old one. Now all I have to do is put that in the username in backticks, so it will execute right away. So that's what goes in where I was trying to do a ping here, is that /star/win. And I run that. Okay, I'm getting some nonsense here. Oh, it went to something.com. I fouled it up somehow. All right, let's refresh this one and see if things are working. They are working, okay. Let's try that again. I put in that junk, /win in backticks. Okay. Okay, now it may have run. And let's just see what's in that file now. Yep, that won. So it did execute it. So all I had to do was solve two problems. I had to deal with uppercase only, and I had to somehow perform code execution, and I didn't even need to match the syntax or anything, because I can just put something in the middle of a command in backticks, and it will execute first, then return it to the rest of the command and have a syntax error. Now there is a more scientific way to do it, which is this one here. Here's where you actually complete the command. You use end the quote, then end the command by using <dev/null. So the original command, which was an egrep, this is the command that's being executed. Egrep username. So in the username, I'm going to put, let me just put that down here so I can show you what happens. That's the original situation. When I put this junk in for the username, then I will get this. And so this will be egrepping some junk here with a close quote, and then from dev null, that will end that command, although I'm a little troubled about this backslash not appearing again. But then I have, he defined a pwn variable to temp/pwn, and what this did, this guy was quite clever in his blog. This is a bash command that changes the case of the characters. So remember, this is all going to be changed to uppercase by the Perl code, and this will change it back to lowercase again, so it will run. So I thought that was pretty cute. This is a pretty sophisticated solution. And when I did it, I just did it this way. I used the %22, which is the quote, and the dev null here. One thing that's tough about this is you have to URL encode the semicolon. If you fail to URL encode the semicolon, it misunderstands the semicolon as a separation between parameters. And you want all this junk in the username. And you don't want, so anyway, you have to URL encode the quotes and the semicolons, and then you can run the // win here. Anyway, so that's another way to do it. And there are always many ways to do it. The most important tricks here that I saw are using the backticks in the middle of something, so you do not need to even match your syntax or anything, and how to, and a star in the path. That's kind of interesting. I guess it must try every directory in the system in alphabetical order or something. That's a strange syntax I've never seen used before. Anyway, that's all I brought, was 3 challenges from here. Have you got any questions out there?
I'm actually just, I can't look up for the white badge.
Good. Okay, the white badge. Let me bring it up. I think other people are doing that too. So let's see. The white badge is here, Pentester Lab.
Oh my God, except for the pickle execution one.
Oh, the pickle one. All right, let me see. All right, so, the white badge. Oh, good. Well, I did all these, so I hopefully know the answer. JSON, double D, pickle code. Oh, okay. Yeah, all right. Let me bring it up here. And this one has an online version, online access. Okay. What I'm going to do is stop the video and break it in 2 pieces because I'm not supposed to publish anything about this one. So the person online, you'll have to come back in just a minute. I'm going to stop this one.